Welcome to a new problem solving session, and this problem belongs to the kinematics of rigid body rotation. And here is a problem at the screen. The statement says there is a heavy disk of radius r. You can see rolls on two inextensible threads wound around it. The free ends of the threads are secured. That means they are talking perhaps about this point. And the threads are constantly taut as the disk moves. At a certain moment, the angular velocity of the disk is omega, and the angle between the threads is alpha. This angle. What is the velocity of the center of the disk at this moment? I don't know what can be the velocity. But whatever it is something. I know I want to name these points A and B. These two contact points, thread and the disk. And I'm going to put an observer at the center of the disk, so that with respect to the observer sitting at the center of the disk, velocity of point B will be something in this direction and velocity of A will be in this direction, because it's nothing but circulating, something like that. And the threads will be along the tangent. Of course, there is no other way, they can be in any other direction. So their values, that is if I name the center of the disk by O, that means what I'm trying to tell you, that velocity of A with respect to the center and velocity of B with respect to the center, they have equal magnitude, and that will be equal to omega into r. Because these are simple things to observe. And next simple thing that can be observed in this problem, that velocities of point A and velocity of point B with respect to the ground must be perpendicular to the threads, because the threads are inextensible. So that this end of the thread can't be a velocity in this direction, or this end in this direction. So but the ends of the thread has got some velocities. So if they have got some velocities, then their velocity must be perpendicular to the threads. So these are the directions of velocity of A with respect to ground, and this is the direction of velocity of B with respect to the ground. So I can write simply by the principle of superposition that velocity of A can be written as velocity of point A with respect to O plus velocity of O, and in the similar manner we can write velocity of point B equal to velocity of point B with respect to O plus velocity of O. I don't know where is the velocity of O and where is the velocity of no, I know rest of the things. I simply don't know where is and what is the magnitude of velocity of O. That is the part of the question. We need to find the value of velocity of O. And as we know, velocity of A with respect to O and velocity of B with respect to O both have same magnitude, that is equal to omega multiplied by r. And let us assume that velocity of point O has the magnitude equal to B. I simply termed it B. So I'm going to write the vector equations in mood to use the vectors. And I know the velocity of A with respect to O is something like this, and velocity of A is perpendicular to this. Velocity of A is this, so it may be like in any direction you can draw. This is the velocity of B. I don't know the direction, so this is basically, if we add these two physical quantity, I'm going to get the velocity of A with respect to ground. So this is it. And in the similar manner, if I draw the velocity of O, sorry, this was velocity of O. So that if we can add velocity of O and velocity of A with respect to O, we can get velocity of A. That's right. So again, velocity of O will be in the same direction, whatever direction you assume. So this is the sum of two velocities. One velocity, I want to see the picture. The velocity of B with respect to O in this direction. So velocity of B must be perpendicular to this. These two velocities are perpendicular. One is along the radius and another is along the tangent. So I guess here that these points, the vector, the corners of the triangle, they will lie on a circle with diameter V, VO. VO, the magnitude of VO is V with diameter V. They are going to lie on a circle. So the picture was nice. Though I don't know where is the direction of velocity of O, I don't know, and I don't want to know. But these two things have same magnitude. So I'm going to write something like that. Velocity of A, O, and velocity of A, these two are perpendicular, and if I can write everything on this in the same picture, VB and this, no, this cannot be. VB should be this direction, because VB is VBO. VBO is in this direction. VBO plus VO. Oh, I was right. Thank God. For the first time I was right. This must be the vector VB in this direction, and this is VO. They are going to make a circle like this with diameter as VO, and this angle is alpha by 2, of course, because this is the same length and these two lengths are same, then these two angles are going to be same, and sum of both the angles is equal to alpha. So this is alpha by 2 and this is alpha by 2. So what do I need to find out? I can write here that velocity of A with respect to O, this is the right angle triangle. So I can write something like this, that this angle is alpha by 2. So I can write here V naught, magnitude of V naught cos alpha by 2, that is equal to magnitude of velocity of A with respect to O. I can write like this, so that if its magnitude is V and multiplied by cos alpha is equal to omega r, so that we got V equals omega r by cos alpha by 2, and that should be our answer. You can get from the right hand side the same result. So these two will have same magnitude. It seems, because they are both right angle triangles with angles, one angle and one side length same. The second side length is also going to be the same. So otherwise you can find it from Pythagoras theorem. So it's all done. Thank you very much for watching this problem. You should watch the another two problem as well, but because the next and the next of the next to the next problem, they are also based on vectors, and it gives you some kind of insight to solve another problems.